Ueli Schättler, you are working for the Deutscher Wetterdienst. Tell me about your function there.
Yeah, I started actually at the weather service without having any knowledge about the weather, but I started as a software engineer years ago when it came to parallelizing the weather forecasting model on distributed memory computers. So I learned a lot in the years about weather forecasting and how is it working in weather services, operational forecasting. So it's not a purely academic thing we are doing, but we really have to do it day by day. There are many constraints that people from academia perhaps sometimes do not understand. Yeah, this is what I'm doing right now and giving support to the users of our model.
You say user of our model. The model is the Cosmo Model. It's the same model which is being used by Swiss weather forecast, by Meteo Swiss. Just some words about Cosmo. What is special about that?
Yeah, the Cosmo model has been developed in the late 90s. By that time as a non-hydrostatic regional model, which was a very modern approach by that time. And it had a certain kind of success story because it is not only used in Switzerland and in Germany, but also for some other weather services in Europe. And even now with the license model, some weather services worldwide are using it. And not only the weather services, but in our two countries, Switzerland and Germany, but also Italy and other countries, it is used by the academia, by the universities, to teach the students, to train the students on numerical weather prediction. And I think this is really a good success story of that model.
You said it's a non-hydrostatic. I've heard many times this word. What does it mean, non-hydrostatic?
Okay, this is now an explanation from a non-meteorologist.
That's good.
So I explain I beg for pardon everybody if I do something wrong. There are hydrostatic models and non-hydrostatic. Years ago, when you had coarser resolutions of 20, 40, 50 kilometers and even coarser, there was a hydrostatic assumption. This means that if you take a cloud in the atmosphere, it has a certain weight. Because of that weight, it should go down. But there is something, okay, I don't know the English word, Auftrieb. So
convection.
Convection which holds that cloud in balance.
Okay.
And this is an assumption that is valid for coarse grid models. If the cloud is big enough, this is true. But if you have finer and finer resolutions, this is not true anymore. And then you need a full dimensional equation set. Hydrostatic assumption means you do not have to take care about vertical velocity, and you do not have to take care about the full pressure. This is calculated by this hydrostatic assumption. But now non-hydrostatic means we have to take care of vertical velocity and of full pressure in the atmosphere. From the computational side, this means you have to add two equations, you have to add two variables, you have to add more computing power.
Okay. Now we know that computing power is always limited, and we know that there is a new project in the HP2C, High Performance, High Productivity Computing Initiative in Switzerland, dealing with the Cosmo model. Can you tell us what we are trying to do there? And if I understand well, you are also part of this project.
Yeah, we were asked to take part in that project because DW still is a major developer of the Cosmo model, of course. And yeah, what we are trying is to investigate modern types of computer architectures. What is coming into all our computer halls in few years' time, even now, is this multi-core up to many-core architectures and even accelerators like graphic cards or the mic from Intel, which is similar to that. So, and to really use these accelerators or many-core architecture, your model really has to be very scalable, and you have to take care. Perhaps you have to use different languages to make use of graphic cards of these accelerators, something that we do not like too much. We are Fortran programmers, and we would like to have a portable I would not say old-style programming model, but what we need is a portable programming model. I mentioned all the weather services, all the universities, they run the model on different types of computers, down to a laptop, to a PC, or a Mac. And this has to be or we want that to be the same even in the next years. So, two things, you have to investigate new hardware. How can you port your model to that new hardware? And how can it stay portable? And I think that these things are addressed, at least testing the new hardware. This is addressed in HP2C. And another thing, to teach the developers how to deal with this new architecture, how to deal with new programming paradigms. And this is the good thing about HP2C, in my opinion. Yeah.
Now from Germany, you have a special view about HPC activities in Switzerland. What is special about what we are doing now in Switzerland about HPC?
Perhaps it seems to me it is much more, centralized is the wrong word, but okay, you are a smaller country, it is much more organized. We have
strategy maybe.
we have similar ongoings in Germany, but at different senders. And sometimes it seems to me that every sender makes the same things and perhaps don't talk too much to each other. So, okay, Germany is bigger, it is sure more complex. But this is what I see is in Switzerland a bit better organized.
Okay. Thank you very much, Ueli, for passing by at our booth at Supercomputing 11. And we wait to see the results of this Cosmo project in HP2C and to have better weather forecasts. Thank you very much.
Okay, thank you.
Thank you.